This is part 4 of logarithms. I want to remind you again of the basic definition of a logarithm is the base b here has to be greater than 0, cannot be negative, and neither can it be 1. But the a up here has to be positive. So when you have log base 10 of negative 4, it's not a real number. Example, natural log base e of negative 1, not a real number. However, it does have a solution which is called pi I, which is a complex solution, and people who have a calculator that can do that would see this answer. We last left off being able to solve logarithms and exponentials, and so I have a bunch of them to work with here. Here's a natural log base e of x equals negative 3. Written as an exponential, this would be e to the negative third equals x, and you can recognize this should then be put onto a calculator and solved, and we get an approximate answer of 0.04. And then we move on to e to the x equals 72. Here we are in base e again. Natural log is base e. And so we would want to get the x by itself by writing this as a logarithm. In this case, a natural log. So natural log base e, right here base e, of 72 is x. And if we look that up on a calculator, we find it to be 4.277. Notice my log rules over here, always there for reference as to what you should be referring to. Another one, simplify e to the exponent to the power, natural log base e of x plus 1. That fits in here with this rule right here where you have a base b and then you have a log with a base b to the a of a, and the solution is a. In this case, then it's a very easy solution because the answer is x plus 1. So this is another look at this as the e rule instead of log base b, e to the natural log base e of y is y. Now this might help you on some problems where you might not see a solution as quickly as possible. Okay, the next one, again, we have a log base 10, understood or implied. We have to get the x by itself. And in order to do that, we're going to write it as an exponential. So this is 10 to the negative 1 equals x. And that's an exact answer. That means 1/10 or 0.1. Easy problem, all algebra. 13 is another exponential. Notice here the 3 needs to be taken away from the x, so we divide it over. And then we notice that base 2 won't work very good with 14 as a base 2. We're going to have to find that, so we write it as a logarithm. Here's the base here, here's the base here. 14 is the number, the value over here. We call this the antilog, where it is equals the exponent x. Notice this is called the exponent. That's the exponent. So because of the base 2, we have to go into base change formula. Once we're in base change formula, we're ready to put it on the calculator. Now be careful with this, with your parentheses and such. Make sure you close parentheses around the 14 here before going on to log base 2. So that completes some more of these problems. Let's try a couple more. Number 14 here, again, log base 10 of x equals 2. It's a base 10, that's called the common log. We rewrite it as an exponential. The best thing you can do is learn how to write logs as exponentials and exponentials as logarithms. This turns out to be an exact answer x equals 100. The next one we go to is another exponential. So we need to get x by itself. The 4 needs to move to the other side, so we divide by 4. This, again, is base e, so I can write this as a logarithm, base e. We're not going to put that down there, but it's there. And 5 over 4 is 1.25 equals the exponent 2x. Divide through by the 2. Put this on the calculator and you get approximately 0.116. You should be writing these down, anticipating at least going through the problems before I do it, and especially put your answer on calculator. There's many times students think they know exactly what they're doing with the calculator and get one after another wrong. Take my word for it, you need to be working on that. Okay, next we go to a problem which is really different, and that is a quadratic type. And we're going to use a method that's used a lot in later math called U substitution. So U is when I notice an e to the x is in several terms, I rewrite the problem, this is the same problem, as e to the x to the second. This is called power on a power, so when I split those powers apart, that is a multiplication. And notice over here I put e to the x and it could have a 1 here. Well, being a quadratic type, I'm going to substitute in u for e to the x. I'll finish and come back later and put that in, and you'll notice it's a little more obvious now. This factors. This is a quadratic factor into u minus 5u plus 1. I set each of these equal to 0, which is the zero product theorem. I substitute for the u, the original e to the x. I don't know what either of those are, so I have to go into natural log base e of 5, and I get that as approximately 1.609. Now over here, this is the first case up above here. You cannot have a u that is negative, and this one does. So there's no real solution to it, no place on a graph. Okay, next one is because we have base 3 log, single logarithm, equal to a base 3 log, single logarithm, the bases are equal, and by the equality rule I can state that the antilogs must be equal. 5x minus 1 is an antilog, and x plus 2 as in simple problem solving we subtract x across and add 1 across to the 7, and we get x equals 2. Looks like 19's next. 2 log base 5 of 3x equals 4. Again, I want to divide this 2 over to the 4. I can't get x out of there unless I write it as an exponential. This is a base 5 to this exponent 2. Dividing 25 by 3 is the solution. The next one is similar but different. We need to take this 5 over with its like term 4, we get a negative 1. The 2 can also divide over to the negative 1, and this is log base e. The x has been left off right here, so that should be an x right there. And so to solve that, we have to get that logarithm and that x split apart, and to do that, we write it exponentially. And this is something we would look on the calculator. Again, make sure you do this with the parentheses around the negative 1/2. Well, I'm going to stop right here and we'll pick this up with part 5 in the next round. I hope this helps you out. Be looking for Logarithms Part 5. This will take